quotient rule. You can see there's a few problems up there to do. For 1, 2, and 3, just do A and C. All right, so this complicated rule is the quotient rule. I'm sure when I taught it to you, I said if you have two functions in x, or whatever letter you're going to use, but in x there, that when you take the derivative of that, it's u dash v minus v dash u over v squared for the derivative. So I think this is the easiest kind of one that looks like that. And I think that's the one that's also on your sheet. Okay, let's do some examples from your book. So in letter A, u is x and v is x squared plus 1. So u dash equals 1 and v dash equals 2x. That's easy. And so my derivative, f dash of x, is equal to 1 times that, so x squared plus 1. I always put brackets on these. And then minus that times that, so 2x squared all over v squared. And then I can simplify that a little bit. I can do x squared minus 2x squared, and I can just get 1 minus x squared on x squared plus 1 squared. Don't square that out. Oops, sorry, lost you there. Don't square that out or do any of that. That's fine right there. Maybe put this up a little bit so I don't get off the page. All right, so in B, u is e to the x and v is cos x. So I have to know all these derivatives. I do have to know that. So you maybe make a list for yourself in a study book or something of what all the derivatives are that you know or should know. I know them. And so I do that the derivative, so dy dx, is equal to u dash v, so e to the x cos x, if you want to use brackets you can, minus that, so minus e to the x sine x, all over v squared, so cos x squared, so I write that, remember, like that. That's just that whole cos x squared. And in your book, you know, they're going to probably say, well, they both have an e to the x in them. They're going to write cos x plus sine x. I got a plus because of those two over cos squared x. And that'll probably be the answer that they give. Okay, let's do the harder ones. And so they want the derivative of this. I don't think it's much harder. There's a 2t in there, which might be a little bit hard, and they want you to do it with respect to t. So I'm looking for dy dt instead of dy dx. All right, so the u is sine 2t. So the u dash is 2 cos 2t. Because after I did cos 2t, I would have had to use the chain rule, so I get the 2 out there. And the v is t squared, and so the v dash equals 2t. Okay, so u dash v. So dy dt equals that times that, so 2t squared cos 2t minus that times that, so 2t sine 2t of 2t, excuse me, and then v squared is t to the 4th. And my guess is that they'd say, well, they both have a 2 in common and a t in common. So I might factorize that out and get t cos 2t minus, I don't know if they did this or not, I didn't really look at it, sine 2t, but my guess is this is what they would simplify it to. And I'd take a t out of the top and the bottom. I think I'm missing a bracket there, but okay, that's my guess. Now, on a test, if you got to there, you would get the answer right. So don't go too crazy about factorizing and doing all that stuff. It's not that important in this scheme of things. If you can, you know, if it's in multiple choice, you're going to have to do it so you know what the answer is. Okay, here we go. It says determine the derivative of f of x, and hence determine the gradient at the point where x is 0. So we know that the gradient is just the derivative evaluated at a point. So we're going to go, okay, u is cos 3x. So u dash equals negative 3 sine 3x. And v equals 2e, I better erase that so it doesn't look terrible, 2e to the x minus x. And v dash equals 2e to the x minus 1. Okay, I like that. So that times that. That's a difference there, so I'm going to need brackets. So I'm going to put negative, let's see, f dash of x equals negative 3 sine 3x times 2x e to the x minus x, excuse me, minus all that. So that's cos 3x times 2e to the x minus 1 all over this 2e to the x minus x squared. All right. Now, seriously, I would just leave it like that. I don't think I would do anything. I guess you can get a no, you can't do anything. You really can't do anything, so just leave it. I think that looks good. Now, anyway, I'm not even looking for that sum. Really, what I want to know is at x equals 0, what is it equal to? So I'm going to say, okay, f dash of 0 is going to be my gradient. Okay, my gradient is going to be when x is 0. So negative 3 sine of 0 times, remember e to the 0 is 1, so 2 minus 0 minus cos of 0 times e to the 0 is 1, so 2 minus 1. Make sure I'm on the page still. Scooch. There we go. 2 e to the 0 is 1 minus 0 squared. All right. So this thing is just one big multiplication, and sine of 0 is 0. It's one of the boundary values. It's 0, so that's gone. So this answer is 0 minus, and cos of 0 is 1, and 2 minus 1 is 1. So 1 times 1 is 1. And then down here I get 2 minus 0 is 0, 2, and 2 squared is 4. So the answer to this is negative 1/4. And that's that. Do the problems at the top.